Hey guys, welcome back to my YouTube channel. So in this last lecture, we are detailedly see about how the decimal and what are the types of systems that is available over there. So last class we discussed about the conversion from decimal to binary. So in this class, let's start with our discussion on the decimal to octave conversion. So we know that when we are converting from one base to another base, we have to repeatedly divide the fraction integer part with the required base. So here the required base is 8. So if we continuously divide it, then the remaining is 4 and the remaining is 5. Then again if we divide it by 8, then 0 and the remaining is 5. So if we write in this way, then 4, 5. This is the integer part that we will get in the 8 base radix. So for the fractional part, we have to repeatedly multiply by the required base. So here that is multiplied by 8, right? So here the answer will be 2.5, and then skip the integer part and just multiply the fractional part with the 8. So here we will get it is a 4, 4.0. So if we write from here, then we will be getting 45.24. So this is the converted value that we will get if we convert that from decimal to octet. So I hope this is not a confusing factor for you guys. So here let's take some kind of observations. Like here you see the conversion from 38.3125. So here this is in a decimal format. So let's compare it in our normal decimal thing. You guys may feel that this number is bigger than this. So this is why it's happening is that the current base is actually higher than the required base. So that's what the conversion is. That's what the difference is resembling here. So here whenever the current base is less than the required base, then we will be getting the number to be higher. So here if you see the current base is 10, but required base is 8. So here if you see the required base is lower than the current base. So ultimately the value here the present will be less than here. So that is what one comparison. If we have finding the conversion from 10 to 16, like if you are going to convert it from hexadecimal, from decimal to hexadecimal, then you may feel that this number will be quite lower than this one. So this is why, because the required base is more than the current base. So this is what the simple thing that we have to remember. So whenever the required base is lesser, then the value we will be obtaining will be more. So this kind of observation that you guys please make note of it. So these will help you guys to grasp the concept very easily. So if you guys were converting to any other things, like let's take an example that you are converting from binary to octave. So if you guys are converting from binary to octave, so then this case what will happen? Let's take an example that we are having 1011.01. So this is the number which is in the 2 radix. So if we need to convert it into octave, we know that 2 power 3 which is equal to 8. So this is binary. So we need to club 3 integer in order to get the 8. So let's club 3. So here there is not another one number is not there. So just you can add 0 here. So decimal we had 0 there, then that is not a problem. So here you can add 0 before if you guys didn't have. So here 3 digit and here 3 digit. So here 2 zeros you can add it. Okay. So if we club two numbers, what will happen? So we know that how to write this, how to convert this into normal thing, like 1011 is the thing there, right? So if we take first 3 bit, it need to be multiplied by 2 power 0, 2 power 1, 2 power 2, so that we can get the decimal conversion. So we are going to convert the 3 integer to decimal, then we will be able to get to the octet here. So that is how we are going to do here. So here if we do these two parts only have the thing. So from right hand side, if you see the first bit and second bit only have the value. So 1 into 2 power 0 which will be equal to 1, because the 2 power 0 is 1. Then 1 into 2 power 1 which will be equal to, if we add 3, then if they add by both, then we will get 3. So this number is 3. Similarly here also there is 1, 2. So this is also 3. And this is 1, 0, 0. So this is 1. So 133 dot. So this one is 2. So this is the conversion in octave. So this is how we have to convert. So let's take a second example that we are converting from binary to hexadecimal. So binary to hexadecimal. So if we convert like this, let's take example that is a 01011. 0 1 1 dot 0 1 0 0. So here 2 power 4 is 16. So here how we have to do? We have to club 4 digits. So this 4 into 1, this 4 into 1, this 4 into 1. So we can clearly note that this is 1, 2, this is 4, that is 0, so skip it, this is 8. So if we add it, the number is coming as 11. So 9 is 9, but 10 is A and 11 is B in hexadecimal. We know, we have already seen in the last class. So this can be written as B. So this one is 1, 2, 4. So this is 5. Okay. This is dot and this is 4. So the answer is 5B dot 4 into hexadecimal, that is 16. Okay. So this is how we have to convert from one to another. The converse is very easy here. So third thing is that the converse of this. So this is octave to binary. So this is just an reverse version. So if there is giving some number like a 23.2 and which is in octave version, we have to separate each digit into 3 bits in a binary. So 2 how can we return that as a 0 1 0. So because this is 2 power 0, 2 power 1 and 2 power 2. So if we add it, we will get only this number is only 1. So 1 into 2 power 1, which will be 1. So 3 can be written as 0 1 1 dot. Then 2 can be written as 0 1 0. So this is how we can convert from octet to binary. So the fourth one from hexadecimal to binary, which is also similar to that. So if we have 23a dot 2, so this is in hexadecimal. So if we are converting that to binary, then simple. Let make the take the digit and make it into 4-digit binary. So which is 0 0 1 0. So 3 can be written as 0 0 1 1. We know that a is 10. So 10 can be written as 1 0 1 0. Here you see 1 2 4 8. So present digit can be added. So 8 plus 2, which will be 10. So that is what here coming. So 1 0 1 0 dot 2 can be written as 0 0 1 0. I hope it is understood for you guys. So this is how we will be converting. So generally how the number system will turn is that, let's take a 3 bit. So first let's start with 0 0 0. Okay. So if one number is added, then 0 1. So this first digit, this is second digit, this is third digit. First digit max capability is 1. It can be 0 or 1 only. So it's reached its max position. Then what will happen? It will flip the next bit. So 0 1 0. It flipped, right? So it will be turning to 0. Okay. Then what we can do? We can again increase this one. So 1 0 1 1. Okay. Then it's reached its maximum. So it will need to flip this one. So this one is already 1. So this need to flip this one. So then it will become as 1 0 0. So then let's flip this one. So 1 0 1. So it's reached its max. So 1 1 0. Okay. Now if we need to flip this one. So 1 1 1. I think you got the point, right? So if we flip the next one, this need to be flipped to 0, this need to be flipped to 0, this need to be flipped to 0, and carry will be 1. So this is carry, cy, because here we are taking only 3-bit system. Okay. In the 3-bit system, only 3-bit. If a digital counter is has only 3-bit, it can represent only 3-bit. For an example, in your watch, if you have only 4 digit like a 12 30, then what will happen? If even if we increase, it won't go to the next state. If it is coming to 99, then it won't go to 100. Actually it will turn to 100, but this one will not be visible for us. So it will be starting from the scratch. So that is what we are doing here, that it starts from scratch. So it will go back to this condition. So it will start from scratch, but the carry will be 1. So this is how the number system will work. So you can even have a shortcut that you can see here, the 4 pair 4 0, here 4 1, here 2 0 2 1. Here you see 2 0 2 ones are there. Then 0 1 0 1 0 1 0 1 0 1. So this is one kind of shortcuts, and you can see many numerous crazy facts here, right? So this is how they will say digital electronics one of the craziest and easiest subject. So here you can see this. This is how we can remember. You can use our normal foundation, like how 0 can be written. So 0, which is equal to 2 power 2 plus 0 into 2 power 1 plus 0 into 2 power 0. So if we do, we will get 0 only. So that 0 only we have written like this way. So this is one of the trick to memorize. So 0 1 2 3, this is 4, this is 5, This is 6 and this is 7. I hope you guys enjoyed this one. So these kind of shortcuts, I have many things to explain, and we can be moving the session very crazier way. So please like, share, and subscribe the channel so that you guys will be get notified on all of the lectures I am posting. So that you guys will also be able to get benefits. And also I am putting another one of the shorts video that where only the important core interview questions asked. So that also will be helpful for you guys. So like, share, and subscribe the channel. So please stay tuned for the next lectures.